All right, Algebra 2 guys, this is section 5.3 notes. We're going to start off just by graphing, just to kind of shake the rust off. So if I say x squared minus 2x minus 3, identify the y-intercept, the vertex, and the axis of symmetry. Well, y-intercept is easy. Y-intercept is just what's on the end here, the constant. Vertex, axis of symmetry, so that's going to be negative b over 2 times a. So that'll be negative 2 over 2 times 1. So that's going to be positive 1. So my axis of symmetry is going to be at positive 1. So it's going to be right there. My intercept is at negative 3, so I can reflect that on the other side. Vertex, the x value is going to be 1 if I put 1 in there. 1 minus 2 minus 3. So that's going to be negative 4. So it's going to be right there. So now my zeros, by graphing, should be at, I get 3 and negative 1. Okay, now what if I'm not sure? Well, if I'm not sure, I can check on the calculator. So if I bring up my calculator, here's what I can do, and here's kind of what's slick. So clear this out, go to y equals, actually first off, make sure stat plot isn't on. It's off, good. Go to y equals, put exactly your function in. So I'll have x squared minus 2x minus 3, graph it. Okay, right now that looks weird because our window is weird. Okay, so if we go up and hit window, yeah, look, our x minimum is 0, x max 60, y min 0, y max 1100. So that's like you're looking only at the positive value. So let's match what we got over here on the right on our graph with what our calculator says. So it says x min 6, x max 6. Let's go scale of 1, negative 6, 6, scale of 1. Don't worry about resolution, keep that fine. So that is what our graph looks like roughly. Where does it cross the x-axis? Where's my zeros? It looks like 3 and negative 1. That is going to work. Now, if I'm not 100% sure what my zeros are, I can always use calc. Calc is across the top, the fourth button over. You'll see it in blue. So if you go to second here, you'll see calculate. What this will do is this will go onto your graph and calculate and figure out what your answer is. So I want a 0. That's what we're solving for. So I want a 0. So you see where it says left bound. I'm going to say, okay, I'm going to go to the left of the area I want to look at. Right bound, I'm going to go to the right of the area I want to look at. So I'm going to go to the left of where I think my 0 is and to the right of where I think my 0 is. Yeah, guess in between there, and I get negative 1, 0 for an answer. So I can do that with the other one. That can help me verify what my answer is. All right, so solving quadratic equations by factoring. Factoring is an easy way to figure out what your zeros are using what's called the zero product property. And here's what the zero product property says. In words, if two things multiplied are equal to 0, if the product of two things are equal to 0, then one of those two things must be equal to 0. All right, so in my example, if x plus 5 times x plus 7 equals 0, if there's a product that equals 0, then one of the two things must equal 0, or both. So what you are looking for is take each piece, set it equal to 0, and solve it. So if I'm trying to set the equation to 0, factor completely, set each factor equal to 0, and solve each equation. So first rule of factoring. Factor out what's in common. First rule of factoring, factor out what's in common. So here, first thing I want to do is set it equal to 0, so I'll subtract 6x over. First rule of factoring, factor out what's in common. There is an x in common here. Once I do that, I create a product. All right, I look at that, I think of this as two different things. There's my product, so that means x equals 0 or x minus 6 equals 0. So either x equals 0 or x equals 6. There is the zeros, and that translates onto my graph. My zeros would be here at 0, and over here at 6. That would be my zeros. Okay? For this one, what I like to do is when factoring, I like to keep x squared positive. It just makes life easier. I don't have to mess with anything. So I'm going to subtract 5x over, subtract 14 over. So now I factor this. Now here's how I like to do factoring. I like to think of factoring. Factoring, you're pulling something apart. You're taking something complicated and you're making it simple. So you're kind of anti-multiplying, okay? Factoring is kind of pulling things apart and working backwards. And this idea of working backwards is kind of how I like to do it. Because working backwards, here's what I do. I go from right to left. I start with this number, 14. All right? So I got to think about what multiplies to 14 but subtracts to 5. So what multiplies to 14 but subtracts to 5? Okay, and then that's going to be obviously 7 and 2. So now I look at this sign. That is negative. If that's negative, that goes with the bigger number. So 7 is bigger than 2, x minus 7, x plus 2. So that means x minus 7 equals 0, or x plus 2 equals 0. So x equals 7 or negative 2. In factoring, one of 4 things is going to happen. All right, you're either going to have plus plus. If that's the case, when you factor it, you should have x plus something and x plus something. Or you're going to have plus minus. So x squared plus bx minus c. Or no, let me flip that around. It's minus plus. So if I have x squared minus bx plus c, that's going to be x minus something, x minus something. They're both going to be subtraction. Then, so for my second sign to be positive, both my solutions, my signs of my solution are going to be the same. If I've got negative, like I did in the problem, that means I'm going to have one of each, and this sign goes with the bigger number. So second sign negative, one of each. First sign goes with the bigger number. So let's take a look at this one. X squared minus 16x plus 64. This plus right here tells me my answer is going to be x minus something and x minus something. All right, this tells me that it's the same. This tells me what it is. So it's x minus something, x minus something. Now, what multiplies to 64 but adds to 16? Well, that's really easy, 8 and 8. So I have x minus 8 and x minus 8 equal to 0. So x is going to equal 8. So what that means in the context of a graph is real simple. All that means is out here at 8, the graph comes down, touches, and takes off again. It only touches once. That's what happens if the answer shows up twice. For number 4, 3x squared minus 9x equals 0. Subtract 9x over. So that's going to be, well, I got 3x in common. So that'll leave me with x minus 3. So either 3x equals 0 or x minus 3 equals 0. So if I divide by 3, 0 divided by 3 is still 0 or 3. There's my solutions right there. So now this one gets a little trickier. Okay, this one gets a little trickier. So if I pull everything over, again, I like to keep the x squared positive. So add x, subtract 1, add x, subtract 1, that equals 0. Now, I can't just start working backwards yet. I've got something in front of x squared. All right, so I've got this kind of situation where I've got ax squared plus bx plus c equals 0, where a, b, and c are numbers. What I like to do is this. It's kind of one systematic way to do it. Take a times c. So take this first number times the last number. All right, so in our case, that'll be 6 times 1, which is 6. So now I want factors of 6 that subtract to get 1. So what multiplies to 6 and subtracts to get 1? Well, 3 and 2. So now here's the tough part. I want to rewrite that middle term. I want to rewrite positive x using 3 and 2. So what that'll look like this: 6x squared plus 3x minus 2x minus 1. But Mr. Heeren, all you did was create more to the problem. I don't get it. Well, here's why I did that. I did that to do this. Now I'm going to group these things. All right, notice when I put parentheses around the second two, if this is minus, I change this sign. So 6x squared and 3x, I can pull out something in common. 3x is in common there. That gives me 2x plus 1. 2x plus 1, that gives me nothing. So I just leave it as is. But take a look. 2x plus 1, 2x plus 1. So the way that looks like is with this. What that looks like is this. Now, where did this negative 1 come from? It came from right here. It's like I have a 1 out front of it, so I pull it apart. So that's going to be 3x minus 1 times 2x plus 1 equals 0. So that means 3x minus 1 equals 0. 2x plus 1 equals 0. So that's going to be x equals 1/3. X equals negative 1/2. All right, so again, let me tell you what I did. A times C gives you a number. Find factors of that number that either add or subtract to get you B. Then rewrite the middle term using the factors you came up with. Then group them. Pull out what's in common. If you do that, what's left in parentheses should be the same, and then set each part equal to 0. Okay, that's probably the most complicated one you're going to see. All right, 6 is one that's actually easier than you think it is. Think about it like this: 0x minus 25. Okay, so there's no x term, so I'm going to kind of create one, and I'm doing that for a reason. Take a look. What multiplies to 25 but subtracts to 0? Multiplies to 25, subtracts to 0. Well, 5 and negative 5. 5 and 5, really. So 5 minus 5 is 0. So if this is negative, remember I have one of each. One x plus, one x minus. They both got to be 5. So that's going to be 5 and negative 5. So write a quadratic equation. So now we're going backwards. So now we've got negative 5 and 7. So now we're thinking about, okay, on a graph, at negative 5, I got a 0. At 7, I got a 0. You know, what is that going to look like? Well, I got to think about this. X minus whatever my factor is times x minus whatever my other factor is. All right, so if I take x minus negative 5 and x minus 7 and I multiply them together, that's going to give me my quadratic function. So I take x plus 5 times x minus 7. This is where foiling comes in. First, outside, inside, last. And if you're clever, you look, that's like a little happy face. So it's x squared minus 7x plus 5x minus 35. So together, that'll be x squared minus 2x minus 35. It's always going to be x minus whatever's there. All right, so if it's negative, it becomes x plus. If it's just a positive, it becomes x minus. So if I got negative 1/3 and 4, so that's really going to be x plus 1/3 and x minus 4. So again, multiply. First times first is x squared minus 4x plus 1/3 x minus 4/3. So that will be x squared minus 3 and 2/3 x minus 1 and 1/3. There's my answer. All right, so write a quadratic equation in standard form with the given roots. So we gave you the roots, now pick off the roots. So if I've got 0, I've got 4. So what does 0 look like? Well, 0 and 4 are my roots, so that's like x minus 0 and x minus 4. Well, x minus 0 is just x. So hey, let's distribute this and make life easy on ourselves. So x squared minus 4x equals 0. There is my standard function. All right, the height of a parallelogram is 4 millimeters more than its base. If their area of parallelogram is 221, find the base and height. So let's draw a picture here. So the height of a parallelogram is 4 more than its base. So if I let this be the base, all right, the height is going to be 4 millimeters more. So it's going to be base plus 4. The area is 221. So area is base times height. So base times base plus 4 equals 221. So b squared plus 4b equals 221. So if I bring that over, what multiplies to 221 but subtracts to 4? Well, let's take a look and see what I get. So now here's where I got to kind of mess around a little bit. Multiplies to 221 and subtracts to 4. So if I quit out of this, so let's see, how about 221 divided by 7? Nope, not even close. 221 divided by 13. Hey, look, I got it. 13 and 17. So that means this is going to be b plus 17, b minus 13. Now, why is it that way? Because remember, that's negative. That means I get one of each sign. This sign goes with the bigger number. It was 17 and 13, so it's b plus 17, b minus 13. So that means b equals negative 17 or b equals 13. Now, here's where I got to think. Can I have a negative length? Absolutely not. So b equals 13, so that means the base is 13, the height is 17. All right, last one, or at least last one I'm doing. Height of a triangle is 3 meters less than its base. If the area of the triangle is 44 meters, find its base and height. So the base is b, the height is 3 meters less, so b minus 3. So the area of the base is, the area of the triangle is 44 meters, so that means base times height divided by 2 equals 44. So now let's make life easy on ourselves. Let's multiply both sides by 2. That cancels that out. I'm left with b times b minus 3 equals 88. So b squared minus 3b equals 88. B squared minus 3b minus 88 equals 0. So what multiplies to 88 but subtracts to get 3? Well, 8 and 11 fall into that category. This sign is negative. That means it goes with 11. So when I factor this, it's going to be b minus 11, b plus 8 equals 0. So that means b minus 11 equals 0, b plus 8 equals 0, b equals 11, b equals negative 8. So 11 is the base, 8 is my height. That's all I got. Go back and rewatch this. Factoring is one of the biggest things you need to be good at for pre-calc and beyond. So get good at